on civil engineering issues.
Thank you. Thank you very much. So, good afternoon, everybody. My name is Tomoyuki TAKABATAKE. I am assistant prof of this Waseda University. So first of all, welcome to Waseda University. And how is Waseda? Are you enjoying it? Okay. So anyways, I'm very happy to give you a lecture today in front of you. Today's lecture title is Disaster Prevention and Mitigation for Sustainable Society. But we are talking about this. We are starting the lecture. Let me introduce briefly about our major, CE major. So the CE major is a short name of the major in civil and environmental engineering. In the CE major, there are a variety of people, variety of faculty members, and a variety of students. And we are dealing with a variety of things. So essentially, if you come to our lab, if you come to our CE major, you will also be able to learn a variety of things. But essentially, CE major is related to these topics: conservation of the natural environment, improvements to human environments, and the safety of human society. An important thing is, we always try to consider these topics from a global point of view. And a CE major consists of mainly three different sections. One section is social infrastructure. So there are a number of professors who are studying about social infrastructure. The objective is to design, construct, operate, and maintain social infrastructure facilities, such as traffic facility, urban facilities, and energy facilities. So in CE major, of course, you will be able to learn how to design, how to construct, and how to operate, how to maintain social infrastructures from these professors. You also be able to learn city planning and management. There are some professors who are studying about city planning and management. For example, some of them are studying about size, location, and spatial construction of cities and regions, and urban mobility and traffic systems. And one professor is studying about urban landscape. Studying about urban landscape is quite important for civil engineers. Why? Because imagine, if you construct very huge social infrastructure facility, that facility might destroy landscape. So it is very important to understand the effects of social infrastructure on the landscape. Of course, in CE major, you can learn that landscape. The last section is environment and disaster prevention. I myself actually belong to this environment and disaster prevention section. So there are many natural disasters. There are a variety of natural disasters. What kind of natural disasters do you know? Earthquake, tsunamis, storm surge, high waves, river flooding, heavy rain, land subsidence, liquefaction, wildfire. All of them are categorized as natural disasters. So in this CE major, we, professors, assistant professors, teach you the history of natural disasters and the mechanism of natural disasters, and also the recent ideas and recent technologies that propose to protect people and properties from natural disasters. So today, I got a chance, so I would like to talk more about these natural disasters. Essentially, I would like to show you what we have done so far to protect the people and property from natural disasters. So look at the slides. Let's start with the pictures. So these pictures, all of them were taken after the disaster events. The first one was taken after the 2011 Tohoku earthquake and tsunami. As you might remember, in 2011, significant tsunami came to Tohoku region in Japan, and unfortunately many people passed away. In 2013, very big typhoon came to Philippines and caused significant high waves and significant storm surge. And unfortunately, approximately 7,000 people passed away. Last year, Indonesia experienced two significant tsunami waves. One of them is this event, 2018 Palu tsunami. And unfortunately, approximately 2,000 people passed away as a result of this disaster. See, before tsunami came, there was a house, and people were living here. Tsunami destroyed many things that had been located near the coastline. So of course, this is a problem. We have to solve this type of problem as a civil engineers. So when engineers would like to solve a problem, we use, generally speaking, 4 different approaches. Namely, theoretical approach, empirical approach, numerical approach, and field survey approach. Of course, all of them are quite important. And in CE major, we will teach you all of the approaches. And our research and what we have done so far is, of course, based on these 4 approaches. And today, I would like to show you some example of each approach. Mainly, I will talk about field survey approach, experimental approach, and numerical approach. Okay? So, let's start with the field survey approach. Let me give you an example. So, as I said previously, last year, significant earthquake occurred in Indonesia. More specifically, September 28th, 2018. A large earthquake occurred on this island, Sulawesi Island, Indonesia. And a significant tsunami came to this place, this coastal city named Palu. And as a result of earthquake and associated tsunami, unfortunately more than 2,000 people became fatalities. Approximately 1 month after the event, we actually went there. We went to Palu. Our purpose was to collect as much information as possible. And we tried to measure the height of tsunami that came to this area. And we also tried to observe the damage to coastal communities. This is our survey team. So 3 faculty members from Waseda joined the survey. He, and actually this is me. Okay? He is a team leader. He's a Professor Tomoya Shibayama. Professor Tomoya Shibayama is one of the top researchers in the field of coastal disasters. And he has nearly 40 years experience of teaching at the university, not only to Japanese students, but also to international students. He is a Professor Miguel Esteban. He's also a professor in the CE major. He is from United Kingdom. Of course, he's a native English speaker. And this is me. So, as you can see, there are a variety of faculty members, there are a variety of teachers in this CE major. Some of them have a long number of experiences of teaching at the university. And some of them are non-Japanese, I mean the international members. And some of them, like me, are relatively young faculty members. So I believe this environment is pretty good for you to study civil engineering and also to enjoy the university life here in Waseda. So who are the others? One is actually our student from Waseda University. And some of them are associate or assistant professors in the different universities in Japan. And some of them are from Indonesia. And one professor is from University of Hawaii, US. And we also have a Canadian PhD student and German PhD student. So our team is indeed international team. So, what is the purpose? Our purpose was to measure tsunami height. We wanted to measure the tsunami height. How we can and how we should measure the tsunami height. We use device, something like this. Let me show you the video. So this is a coastal disaster area. We took video during our survey. So we are using this type of device, and actually this is me, and we are using this device. So by using these 2 devices, we can measure the distance and difference in elevation between these 2 places. By using this type of technique, we can measure the tsunami height. Okay? If you'd like to know the information, if you'd like to know more information, I suggest you to take a course next year. Okay? We have a courses in which you can learn survey technique, surveying and survey practice. Anyway, today, let me just show you the results. So this is a measurement of tsunami, our result. This colored circle shows tsunami heights. So in this figure, for example, the green color means 3-meter tsunami. Yellow color means 4-meter tsunami. Orange color means 6-meter tsunami. And red color means 7 or 8-meter tsunami. what we can say from this figure? What we can say from this figure? So from this figure, at least we can say at the entrance of the bay, tsunami heights are not so high. But here, at the end of the bay, tsunami heights are relatively high, more than 4 meters or 5 meters, sometimes 8 meters. This type of information is quite important when determining the height of seawall and when establishing evacuation plan. So according to the result, at least we can say, compared with this area requires higher seawall and more effective evacuation plans in order to protect the people from future tsunami. And we also observed the coastal damages in disaster area. We took these pictures. As you can see, if tsunami comes and if tsunami height is so significant, many things will be destroyed. Let me introduce our cutting-edge survey technique. So what is this? Maybe you have seen this. This is UAP, in other words, drone. So we use the drone during our survey. The person who is manipulating the drone is our student. He is a pretty good student, a master student in Waseda. So by using the drone, what we can do? We can take aerial pictures. Here, there is a camera. So by using the drone, we can take aerial pictures. By using aerial pictures, what we can do? We can create this type of picture. This is a 3D picture. So by using this type of 3D picture, what we can do? We can more precisely observe and we can more precisely analyze the damaged buildings. So this type of technique is nowadays quite important. Okay? So this is the survey approach. Experiment. This is also important for engineers. In order to protect people from natural disaster, we need to conduct many experiments. Why experiments are quite important? Because unfortunately, the existing theory in the field of civil engineering is not that perfect. Sometimes we have phenomena that are very difficult to be explained only with existing theory. In that case, we have to conduct experiment. And by conducting experiment, we need to clarify the phenomena. Okay? And experiment is also quite important for you, students, to understand the physical phenomena and existing theories. So in the CE major classes, we have a number of courses in which we teach existing theories. So in the normal classes, we generally use mathematics. But we understand it is very difficult to understand the physical phenomena and theories only from mathematics and only from oral explanation. So we prepare several experimental courses. Through these experimental courses, you can observe the physical phenomena with your own eyes, and you can deepen your understanding of your existing theory that are taught in the classes. And also, you can deepen your understanding of the physical phenomena. So let me show you some examples. Okay? So, for example, in experimental class, you can observe something like this. Water flow over a dam. And you can also observe waves generated in the flume. So of course, in normal classes, we teach you the theory of waves, mechanism of waves. But we understand it is very difficult to understand the mechanism of wave only with the equation. So you can observe the experiment. What we do is by combining the normal course and experimental courses, we always try to raise your level of understanding on the existing theory and the physical phenomena. Okay, so this is an important point. So let me go back to the research talk. So as I said, experiment is quite important for the research. So let me show you one example of experimental research. This is a pod, okay? So this is a pod. And we have several coastal buildings. And as you might know, in a pod, there are many containers placed. There are many containers placed. If tsunami comes to a pod, what will happen? What will happen to containers? Of course, containers will be moved. Containers will be moved. But how containers will be moved? It is actually not well understood. So we conducted an experiment, and we tried to clarify the mechanism of the movement of the container under the tsunami-like flow. We have a device. This is a tsunami generator. This can generate a tsunami. So by using this generator, we conducted experiment. Generate tsunami. Yeah. Containers are moved. So we analyzed the movement of the containers. So this is an example of the experimental research. In addition to this type of experiment, so far we have conducted a number of experiments. And what I'd like to stress here is, when we conduct experiment, generally speaking, we collaborate with people from all over the world. For example, the previous experiment is a collaborative experimental project with the universities in Canada and university in Germany. So, Canadian professor, German professor came to Waseda, and we conducted experiment together. 2 years ago, Iranian professor and Iranian PhD student came to Waseda, and we also conducted experiment together. Last year, 2 years ago, PhD student from University of Ottawa, Canada, came to Waseda, and we conducted experiment. Last year, researchers from Netherlands, they are from Delft University in Netherlands. They came to Waseda, and we also conducted experiment. This year, one student from French University came to Waseda, and we conducted experiment. And actually, 3 days ago, professor from Del Salle University in Philippines came to Waseda, and now we are conducting experiment. And when we conduct experiment with people from all over the world, we generally speaking ask you to work with them. Why? Because this type of experience is quite important for your future. This type of experience will work in the future. So please imagine, in 20 years, in 10 years, you will have to work with people having different background, different idea, different knowledge, different culture. But while you are in Waseda, we can provide such opportunity. While you are in Waseda, you will work with people from all over the world. And some professors have now recently actively working with people in the industrial companies. So you may have chances to work with people at the industrial companies. Anyways, here, what I would like to say here is that our faculty members in CE majors always try to give students opportunities that will be very helpful in the future. Okay? Let me briefly talk about numerical approaches. Numerical approaches is generally speaking a little bit difficult. So let me just briefly talk about this. So this is an example of tsunami propagation and inundation simulation. This is a computer simulation. Computer simulation is also important for civil engineers. This is very difficult, but of course, we prepare the courses in which you can learn programming and computer simulation technique. So this is a tsunami simulation. The red color shows water surface rises, and the blue color shows water surface drops. And we reproduced 2004 Indian Ocean tsunami by using our tsunami simulation model. What we can do with this type of simulation, we can see, for example, when tsunami arrives at a given coastal area. And we can also predict how many meter tsunami will come to a given coastal area, for example, here. So we can provide very important information to people living in such a place. Recently, we have developed a simulation model that can simulate not only the behavior of tsunami, but also the behavior of you, human being. Tsunami evacuation simulation model. So each dot represents human being, evacuee, one person. When we start evacuation, earthquake occurs. When earthquake occurs, many people start to evacuate, go to a safe place. But some people do not evacuate, even after feeling the ground shaking, even after they hear tsunami warning. What will happen to them? Of course, if they do not evacuate, they are caught by tsunami. So we developed this type of simulation model. And by using this simulation model, we would like to provide very important information to local authorities or, for example, local residents. Because if we can provide the information like when they should start evacuation or where they should go, they should evacuate, and how they should evacuate, and which route they should take to go to a safe place. Okay? By using this, we can provide very important information. Oops. We also have simulation models that can simulate the movement of a typhoon and the movement of associated high waves and storm surges. Let me show you the example. So we simulated typhoon. This is a movement of a typhoon. By using computer simulation, we can reproduce typhoon in a computer. Okay? So when big typhoon comes to coastal area, actually this is Philippines. When big typhoon comes to coastal area, what will happen? What will happen? Of course, very high waves, significant storm surge will be generated due to strong typhoon. We also can simulate the movement, behavior of storm surge and high waves. Okay? And also, nowadays, we are trying to predict the impact of future climate change on coastal disasters. As you might know, our planet, our Earth, is becoming warmer and warmer. If this trend continues, what will happen to a typhoon? Typhoon also becomes bigger and bigger. If bigger typhoon comes to coastal area, what will happen? More higher waves will be generated. More significant storm surges will be generated. As a result, more people will be at risk of being hit by storm surge or high waves. Okay? So we would like to know the impact of global climate change. And we developed the simulation model that can predict the effects of future climate change on the storm surge. And now we are trying to predict what will happen in the future. And we are trying to propose effective countermeasures against future climate change. So, actually, from now on, I would like to show you one important numbers. Okay. So, this number. What is this number? 56,000. 56,000. This is actually a very important number. This is actually the annual average number of people who suffer from natural disasters. Average number of people, more correctly speaking, annual average number of people who passed away as a result of natural disasters over the 50 years. So today, I introduce a lot of things. I introduce what we have done so far. As I said, we have conducted a lot of things. We have visited many coastal areas. We have visited many disaster areas. And we have conducted a number of experiments. And we have developed a number of simulation models. But still, this is a reality. Okay? So there are still a number of people that suffer from natural disasters. So we would like to, of course, decrease this number. Okay? Decrease this number. And there are so many things to do, okay? There are so many things to do. So I and we, CE major, faculty members in CE major, I strongly hope that you will join us and study hard and in the future become a professional civil engineers or professional civil engineering researchers and contribute to making the world a better place, okay? And what I would like to say here today is civil engineering. Most important thing is civil engineering is very, very interesting to learn. And civil engineering is very challenging, okay? So please remember this. Civil engineering is interesting and challenging. So as I wrote here, we, the faculty members in CE major, are looking forward to seeing you in the future and teaching you and working with you in the future, okay? So thank you very much for taking this lecture, and please enjoy the time in Waseda. Okay, thank you very much.